All right, we're in geometry. Today's date is Tuesday, October 1st, 10/1, 2019. We're talking about shaded areas today, which is kind of not the best title for the lesson. That's all I could come up with. But the objective is much more descriptive. Who can do that for us? Who can read? Our first hand was definitely Jessica. There it is. So again, you can find the circumference. It's really easy. I probably gave too many questions already, but we'll just nail down circumference and get it down. The main thing that I'm worried about is the difference in area between circles and rectangles. So if you want to take a quick peek at the backside, I'm trying to find this shaded area. I'm trying to find this shaded area. How do I find that? You should be thinking about that while we're working on the front side. Is there a quip over here? No, not a question. All right, we're going on to some vocab. What is the circumference, Gunner?
The circle around the edge of the circle.
Good guess. You still get 50 XP. You can turn in your card, but no, you are not quite right. Again, think about Ant-Man or just an ant. If you're
the guy.
He's walking around the circle. How far he has walked? What's another word for that? It starts with a D. Quiet raised hand. Who's got this? Who has their card still? Sergio? Diameter would be the distance across. And I already said the word. I'll still take your card because you get 50 XP. Jenny? It is indeed distance. Thank you, Jenny. So Sergio and Jenny get 50 XP. And then we're on to... So that's the definition of circumference. If you're an ant walking around the circle, how far have you walked? It's the same idea as if I thought of this as a line. I took an axe and I chopped it right here, and then I rolled it out. The length of the line is the circumference. So I want to talk about pi. You guys know of pi. Does anyone know the definition of pi? How do we even find pi nowadays?
Wait, in the store.
Julian?
In the store.
Ha 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 ha. I am filled with genuine laughter right now. So the definition of pi. This is something that you guys should know if you're taking geometry. The definition of pi, this is what people did way back, this is like before Greeks, essentially. They looked at a circle. They said, I wonder what happens if I get a string and I wrap it around this circle, and then I divide that distance by the diameter. What's going to happen? And the answer was, I keep getting about 3 each time. Let's grab a bigger circle. A smaller circle. They kept doing this where they measured the distance around the circle and divided by the diameter, and they kept getting about 3. Eventually, they became more precise and more precise. They're like, it's about 3.14, and then they're like, is there some way that we can calculate exactly what that is? And we now know that as pi. That's a very brief and semi-inaccurate history of pi, but there it is. Pi, by definition, is circumference divided by diameter. That is the definition of pi. There are a bunch of ways that you can actually mathematically calculate pi with some really fun Maclaurin series and stuff like that, but you won't see that until you hit AP Calc BC. For now, no, it's circumference divided by diameter. So, if I'm looking to find the formula for circumference, I need to do what to both sides with a quiet raised hand? What do I do to both sides in order to solve for C, to find C? No, that's not how it works. Andres.
So you divide both sides by the diameter?
Divide both sides by the diameter?
Yes, sir.
Not quite right.
By 2.
Not quite right.
By D.
Right now, C is being divided by D, the inverse operation of divide.
Multiply by D.
There it is, thank you. Multiply both sides by D. There it is. And then those D's cancel out, and I now am left with the circumference is equal to pi times the diameter. That is one of the formulas that we had yesterday. We can write it down if you want down here. We can say, yes, that is the formula. It's pi times the diameter. But we know that the diameter is what of the radius? What is the relationship between the diameter and the radius? Only one person remembers the... Okay, so again, just so that we have some terminology, if I have a circle, this line across is going to be called the diameter, and if I have a circle with a line that comes like, oh no, I don't want to do that, with a line that comes like that, that is the radius. My question for you is, what is the relationship between the radius and the diameter? Still only one person knows. You literally multiply by a number, guys. You guys got this. Cohen? Exactly. The diameter is twice the radius. If I have the radius, if I multiply that by 2, I can say that this length right here is 2 times r. So I can change my formula now. If I know that the diameter is twice the radius, I can change my formula to 2 pi r. And that's the one that you need to have memorized. There are 2 things when it comes to circles that you have to have memorized for geometry. 1 is the area of a circle. 2 is the circumference of a circle. And you should have those memorized for basically the rest of your high school and maybe college career, depending on what you study in college. 2 pi r. Again, I multiply 2 and r to get the diameter, and still times pi. Is there one of these? Practice making the symbol. Look at the cue. All right, Andres.
Oh wait.
It's pointing down more, yeah.
Oh.
What is it, Andres?
So the formula for circumference is 2 pi r.
Yes.
So you just multiply the radius by 2, and then multiply by pi, and then that's how you get the circumference.
Yep, exactly. And it comes from the definition of pi. Question, Gunnar.
What would you do if we don't go to college? Like none of us. No one in this class ends up in college.
I mean, as long as you're successful and happy in life, I mean, I'm happy.
Successful.
If you're not successful and you're not happy, well, then I'll be slightly sadder.
Slightly sad.
Yeah.
Slightly.
I can't make it a huge toll on my soul, but
I'm living in a box in your front yard.
I don't have a front yard. I live in a condo.
In your backyard.
Sergio, question.
What if they only tell you the diameter?
If they only tell you the diameter, then even easier, because here's another formula. Plug it in there.
Why?
Yeah, you can use either of those formulas. This one on the right is a little bit more standard, but both of those are valid formulas. Let's go to example 1. What is the circumference of the following circle? All right, someone regurgitate the formula of circumference and tell me what to plug in. Sergio, you don't have your card anymore. Leave it there.
You're gonna use math.
Don't use Mathway. Who can do this one for us? Regurgitate the formula for a circle. Jose, go for it.
So you use I.
Sure, we'll say circumference is equal to pi times d. We can use that one. And then what do I plug in?
D is 11.
D is 11. So this d now becomes 11. And then our final answer is c is equal to, Jose? Just switch the order of these.
No, pi.
11 pi. So that is the exact representation, but if I want to approximate it, and I believe tonight every single homework question does not let you type in pi to make pi. They want you to always approximate. So we do need to practice approximating this time. We need to say that c is approximately 11 times, what's the approximation with a new quiet raised hand, someone? What is the approximation of pi that we like to use with 2 decimal places? What is the approximation of pi? Monse, yes. It is indeed 3.14. And this is something that you'll just do on your calculator. You can do this on Spotlight Search. You can do this on Desmos, Scientific, whatever you want to do. 11 times 3.14. 34.54 is the answer that I'm getting. So everyone write it down, 34.54.
69.25.
34.54. And what are our units in this case? Now we actually have some units. We don't just say unit squared, we say what?
Centimeters.
That is minus 5 HP for yelling out the answer. But is there a quiet raised hand? Did someone just die? Oh, I need to do homework as well, don't I?
Oh, you're too. Oh, yes.
Gunnar, you're good. You're good. Yeah, Sergio. Units. Centimeters. Squared. Is it squared or is it centimeters?
Well, then we have to square the
So you still get your 50 XP. It's actually centimeters. Because think about this. If I am Ant-Man and I'm walking around the circle, how far have I gone? I've gone centimeters. I haven't gone centimeters squared. It doesn't make sense to walk an area. Centimeters squared is an area. So if I'm doing area, A equals pi r squared, then it's something squared. In this case, it's just centimeters. This is the distance. Remember, I take the axis of this thing, I chop it open, and I have this length. Length is always just centimeters, or units, not units squared. If I have area, if I have something that's shaded, that's going to be centimeters squared. Question, Andres.
So basically, for example 1, just to narrow it down, it's basically just 11 times pi
Yes.
to approximate it.
To approximate, yeah. 11 times pi. Use 3.14 for pi. Let's do example 2. Let's go through 2 and 3 nice and quick because we're going a little bit too slow on the notes, I think. Example 2. A circle has a circumference of approximately 100.48 units. What is the radius of the circle? Which formula should we be using? One of these two. Someone pick. Quiet raised hand. If we're trying to find the radius of the circle, which one makes more sense to use? Quiet raised hand. Cohen. It is indeed going to be 2 pi r. Everyone write down. Circumference is equal to 2 pi r. Next volunteer. What am I going to substitute in? There's a number that's given to us. There it is, 100.48. Where does that get plugged into? Quiet raised hand. 100.48. Andres.
It gets subbed into r.
That's the radius right there?
Oh no, I mean in c.
Yeah, C, because that's the circumference, exactly. So 100.48 is now equal to 2 pi r. And then what am I going to do to both sides? New volunteer. Quiet raised hand. Sergio Hood. Quiet raised hand. What am I going to do to find r? I need to isolate r. Right now r is being multiplied by 2 pi. Fernando, what are we going to do?
Divide both sides by 2 pi.
Divide by 2 pi. Divide by 2 pi. And there's our answer. So these cancel out and we get r is equal to 100.48 divided by 2 pi. Unfortunately, we need to make this an approximation. I mean, that's the exact answer if it was exactly 100.48 to begin with. We now need to change this into a new equation that says it's 100.48 divided by 2 times, and again, quiet raised hand. What is our approximation of pi that we always use over and over again? Sergio? 3.14. So you can do this on your Spotlight search. You can do this on Desmos. I like Desmos for this type of problem because it makes, or it's a little bit easier to see. So if I come back over here to Desmos Scientific and I type in 100.48 divided by 2 times 3.14, oh, it's exactly 16. So the radius is exactly, well, I mean it's approximated at this point, but we're getting about 16. So we're going to say down here, radius is now not equal to, but squiggly equal to, approximately equal to 16. All right. We should be boxing our answers too. I haven't been doing a good job of that. There's 16. There's 34.54 centimeters. You guys can do example 3. It's the easiest example. Do example 3. I'll give you guys 60 seconds, and then we can move on to the harder material of finding shaded area. Good luck on example 3. You may work together. All right, so the formula for this one, we're going through it fast, so I will do it. Circumference is equal to 2 pi r is a good formula to use because we are given the radius. So I chose an equation that had radius in it. So from there, I'm just plugging in. The radius is 12, so this r is now going to become 12. So I have c is equal to 2 pi times 12. I'm going to reduce this now. This is now equal to 12 times 2 is 24, so 24 pi. I now need to turn pi into something a little bit easier to work with, so I'm going to say that's actually equal to 24 times 3.14, and then I just have to plug that in into my calculator. 24 times 3.14, I come over here and I say 24 times 3.14, and that's about 75.36. So if I come over here, I should do an approximately equal to, that's about 75.36. 75.36. Don't forget your units. Oh, our units are units. Okay, so just units, not units squared. Unit squared is reserved only for area. Circumference is just units, is just a length. Box it. Give me questions on anything that we've done on the front side. If there's no questions, then give me a fist of 5 if there's no questions. How well can you do example 1, 2, and 3 on your own? Fist of 5, go. I see a 5, I see a 4, I see a 4. I see Julian, come on guys, make it easier for me. 4, 4, 4. Julian, if you're going like this, I can't see what your number is. There it is, 4. All right, so I see 4s and 5, thank you. All right, let's do example 4. This one is going to be slightly harder. So I'm reading a circle with a radius of 2. That tiny little guy on the inside is sitting inside a circle with a radius of 5. So this length right here is 5. This length right here is 2. I need to find the area of the shaded, or the area of the shaded area. It kind of sounds weird. I think it's supposed to be shaded region maybe. So this area right here, not this area right here. So does anyone have an idea of how we're going to solve this? It's very similar to our last 2 lessons. Sergio?
You find first the one in the whole and then minus this.
There it is, yeah. Find the area of the small circle, find the area of the big circle, and then do big circle minus small circle. So I'll write out the formula in terms of shapes. Find the big circle area minus the small circle area, and that will equal the shaded region that we are looking for. That's the general idea. So then we need to find the area of the big circle. What is the formula from yesterday to find the area of a circle? Who has it memorized? Look at your summaries. It should have been in your summary. What is the area of a circle? The formula. Not a single person has raised their hand. What is the formula for the area of a circle? Anyone? Josie. Pi r. There it is. Pi r squared. So I'm going to write it down. Pi r squared, and then that's going to be subtracting another pi r squared. If that's confusing to you, you can make one of them r1 and one of them r2, or you can just leave it like that. Strictly mathematically speaking, they should be different r's. So let's go ahead and find what that r is. Can someone help me plug in? What is the radius of the big one? What's the radius of the small one? Jose? So pi times 2 squared, and tell me what to write down now. Oh wait, that's a small one, right? So what's the big one? We're going to do the big circle first.
Oh, so
Pi 5 squared. Tell me what to write.
minus pi 2
Squared. Perfect, thank you. Can you also just simplify this really quick?
Oh, so that's
25
pi
pi
minus 4 pi.
4 pi. All right, we'll leave it there. Thank you, Jose. That's 50 XP. Jenny's on it. So we've basically found the answer, except there's something kind of cool that you can do. Do you guys remember problems? Let me do a problem off to the side. What if I did 25x minus 4x? Does anyone know how to combine like terms there? Quiet raise hand. Who can do this one? 25x minus 4x. Andres, what is that?
It's my card.
How did you get your card back? That's not your card.
It's my card. It's not my card, but it's a card.
Okay, Andres.
Okay. So it'd be 21
21
x.
x. There it is. The same thing can happen with pi. This thing can now turn into 25 pi minus 4 pi can turn into 21 pi. You're allowed to do the same thing. It's kind of like combining like terms. And now I need to actually make an approximation. So we say that 21 pi is approximately equal to 21 times, quiet raise hand. What is our decimal approximation for pi? Jose again. 3.14. The decimal a little bit bigger. So I come back to my calculator and I say, okay, I need times 21 and 3.14. So 21 times 3.14. 21 times 3.14 is 65.94. 65.94. And what are our units in this case? Quiet raised hand. Who can do our units? Josie. What squared? There it is. Centimeters squared. It is squared in this case because we're talking about area. If it's circumference, it's not squared. If it's area, it is indeed squared. There is our final answer. And because we're so low on time, how did our class go by this quick? Let's go ahead and do example number 5 together as well. Is there anyone that can explain, oh, maybe I should slow down because some people are still writing. Actually, we've all written down. Can anyone explain with shapes like this how I'm going to find the area of the shaded region for example number 5? Quiet raised hand. What shapes am I going to be subtracting here? Sergio?
Base times height. So
Oh, you're already, so rectangle minus circle will give us the shaded region. There it is, thank you. Perfect. And now another quiet raised hand. And Jenny's tapping away quietly over there. Thank you. Another quiet raised hand. What is the area of both of those shapes? You need to know two formulas. The area of a rectangle, area of a circle. You should know these now. Area of a rectangle, area of a circle. Fernando Hood. Area of a rectangle, area of a circle. Who's got it? Fernando, go for it.
Rectangles, length times width.
Length times width. Perfect. We can say length times width. I think the official one we had in our notes is base times height, but that is perfectly fine. I'm going to change it from my notes just so it matches. I'm going to do base times height, but length times width, it's perfectly fine. You got it. And then what about the circle? It's minus
Minus pi r squared.
pi r squared. Thank you, Fernando. All right. I need someone else to plug in and simplify for me. Someone else, plug in and simplify. Andres.
So it's going to be 80 minus pi 2 squared, which is 4.
So
Pi-
read the
four
new.
pi.
Yeah, you can simplify. Oh, you're already
80
doing it.
Minus 4 pi.
So it's going to be 80 minus 4 pi, and that is going to be approximately equal to
76
80 minus 4 times.
4 times pi.
What is pi's approximation, Andres? 3.14. And that's what I'm going to do on my calculator. Thank you, Andres. I'll leave this up there for another 10 seconds, and then I'm going to switch over to my calculator and show you guys how to do this. It's going to be 80 minus 4 times 3.14. And here we go. 80 minus 4 times, and I can do times like this, 3.14. Order of operations are still good, and our answer is 67.44. 67.44. Quiet raised hand. What are our units? Only one person knows the units. 2 people, 3 people, 4 people, 5 people. Gunner. Close.
Centimeters squared.
Centimeters squared because area. There it is. 67.44 centimeters squared. Cool. That is all of the examples. Give me a fist of 5 on examples 4 and 5. These last 2 examples with shaded areas, how well do you think you can do them with different shapes, different numbers? I see a 4, a 3. No, it's a 4. It's a 4, it's a 4, a 5. Okay, these are good scores. Let's see how well we can do this. Good luck on the homework. The 2 assignments are up on Khan Academy. One of them is circumference, one of them is shaded areas. Good luck.